Hey, hello and welcome to today's GFG problem. Today, hope you're doing well. So let's see today's problem, Stickler thief. Okay, so what the problem is saying is will be given up. So the problem is saying is Stickler the thief wants to loot money from the houses arranged in a line. He cannot loot two consecutive houses and aims to maximize his total loot. Okay, so we'll be given an array where a array of I represents the amount of money in the ith house. Okay, and we want to determine the maximum amount he can loot. So here, right, we have been given an array and each number represents the amount, okay, present in that particular house. Okay, now what the condition is given is the thief cannot loot two consecutive houses. That is, he cannot loot from this house and this house. Okay, from this house and this house. Okay, so he cannot loot two consecutive houses basically. And we want to help him, like he should be looting the houses in such a way that he earns the maximum. Okay, the maximum amount. Okay, the maximum money. Okay, so yes. So now if you see, right, how we can solve this problem. Okay, how we can solve this problem. So there's no such particular pattern, right? What, like, he can loot this, right? Right, and then this, right? And then definitely not consecutive houses, and then this. Maybe he cannot, maybe he won't loot this. Okay, or he will loot this, and if he loots this, then he will have to loot this particular house, right? So in any case, we have to check all the cases wherein, or we have to check all the paths, right? All the paths wherein we want to find the maximum loot, the maximum amount loot. Okay, so here the question drills down to the choice, right? The choice whether we should take this, we should consider this house, whether we should consider this house or no, whether we consider this house or no, whether we consider this house or no, whether we consider this house or no. So this is a clear case of, I will say, dynamic programming. Okay, because we have two choices. We have to make two choices. Either this, either take or not take, take or not take, right? Take or not take. So what we are going to do? We are going to run a recursion. This is how we are going to solve this problem. We are going to run recursion, and then post recursion we are going to, in order to optimize the time, right, we are going to use memoization. So this is a form of dynamic programming. Okay, so yes, as I said, so we'll start from the last element, from the last house, and we will make two choices here. We'll make two paths. We'll take, in one path we'll consider this particular house, and in another path we won't consider this house. Okay, so when we consider this particular house, then we are going to jump directly to this particular house. Okay, we are going to jump directly to this particular house because we cannot loot this particular house. Okay, and when in another choice, when we are not considered this house, then in that case we are going to consider this particular house. Okay, in that case we are going to consider this particular house. Okay, so I hope you're getting the intuition to solve this problem. So I'll code, I think you'll understand better. Just one request to please subscribe to the channel, like the video. I'll try to make it very easy for you. So I've done the implementation. Let me reset this. Okay, let me reset this. So first I'll show the Java code followed by C++. So what I'm going to do is, so as I told you, right? So first of all, let's take the array length, array.length, right? And then let's find max sum util. Let's call this function. In this function, we're going to pass air and n minus 1, which is the last element we're going to pass. Okay, the index of the last element. Okay, and what this particular function will return? N. Okay, now as I told you, right? So first we are starting from the last element. So we'll make two choices here. We'll take, in one choice we are going to take that element, or we are going to consider that element, and another choice we are not going to consider that element. So when we say we are going to consider this element, right? For example, we are starting from, let me erase this. So we are starting from this particular house. We are in one choice, we are considering. So when we say we are considering, we are going to take array of n. Now array of n, what is array of n? Which is, n is what? N is pointing to this particular element, right? So array of n, we have considered this element 4. Okay, plus find max util. So we have considered this element array. Now we are going to, as we cannot consider the consecutive house, we are going to do n minus 2. So n minus 2 means what? We are directly jumping to this particular house. When we are taking this element, we are jumping to this particular house. Okay, so we've taken this. Now another choice is not to take, right? We want to try all the permutation and combination, right, in order to find the max loot. Okay, so we are not taking this element. So definitely we are not going to add this particular, we are not, as we are not considering that particular element, max 4, we are not considering that. Max util. So when we are not considering, we are going to move to the next element. And which is that next element? So in another choice, we have not considered this element. So we are going to move to this particular element. Okay. Since we have not considered this element, we'll try this particular element. So in one choice, we are moving to 7. Okay. Now then what we are going to do? We are going to simply, we want to return. It may happen that when we took this path, right? When we took this path, that is when we considered 7 and then 5, then it gave maximum. It may happen. Then there may be the case. For example, it 5 plus 7, what? 12. And let's say here it was 2 only, not 6, right? And if we had considered this particular 4, 5, and 2, what would have been the max loot here? I mean, what would have been the loot amount? 4 plus 5, 9, 9 plus 2, 11, right? 11. So by not considering this particular house, right? When we consider 7 and 5, then we were able to find out the maximum loop. So it may happen when we are not taking an element, right? When we are not considering the current element, okay, and when we consider the other elements, then in that case, still not take may be greater, right? And that is why mat.max, we are going to do mat.max out of take and not take, right? Take and not take, and we're going to return here. And here, what will be the base condition? If n becomes less than 0, okay, this is a base condition. So we will return 0 in this case. Okay. And what we're going to do here? Return. Simple. So I hope you're getting the solution. Let me compile this. Okay, some issue. What is the issue here? Arr of n cannot find symbol. Find max util. Oh, my bad. Find max sum util should be. Okay. Okay, now it is matching. Let's submit it. So there's one more thing we need to do. Let's see. Now it should give us TLE, that is time limit exceeded. Okay, it has given because it wants us to optimize the time, because it is like what we are taking. No, we are making two choices: take, not take, take, not take. So the time complexity it is becoming exponential. Okay, so in order to optimize, right? So it may happen. It may happen that why we want to like see. So when we are making the choices like take, not take, then in that case, it may happen that some computations were already done. Some computations may repeat again, In that case, what we'll have to do is we'll have to use memoization. Okay, simple. So let me explain that. So we'll take a DP array, new it. Okay, single DP array we are going to take, and the size will be n plus 1, and we are going to fill with arrays dot fill dp minus 1. Okay, and then what we're going to do, so simple, when we are going to, for example, for a particular n, okay, for a particular n, that is this particular n, okay, we will store the value. We'll store if till this particular n, what is the amount loot, what is the max amount loot. So we are storing in dp of n. Okay, what we were doing is we were initializing dp with minus 1. So here we are going to check if if the computation was already done, if the value was for a particular n, if it was already stored, right? In that case, it won't be minus 1. In that case, I mean, in some particular past call, we had filled this n, right? We had filled this n. So what we're going to do, we are simply going to return dp of n. So we are avoiding again the computations, the repeated computations here. We are avoiding the two calls again. We are returning from here itself. So here we are doing some memory optimization. So let's now compile this. Let's quickly see. Oh, so we'll get some errors. We want to pass dp in the two calls. Okay, and here also we want to pass dp. Again, what is the issue here? Solution dp here. Okay, I missed here as well. Okay. All the test cases are passed. Thanks for watching. Please subscribe to the channel, like the video. Let's quickly see the C++ code as well. So here is a C++ code. Here we have taken DP, okay, of size n plus 1, which is of type vector. DP we have passed. Here BP, okay, and here what we are doing here is we are making the choices. I've already explained this, not much difference in the code, right? And here we are not taking that particular element, and then we are storing the max out of take or not take from into dpn, and when this value we are returning that dp of n. Okay, so thanks for watching. I hope you have got the solution. Please don't forget to subscribe to the channel, like the video. I'll also attach the code in the description section. Thanks for watching. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.